Lesson 7 of Chapter 1 is on inverse relations and functions. This is the last lesson of Chapter 1. Pretty excited about that, I'm sure. I'd like you to read this little paragraph we have here. It says, the band boosters at Julia's high school are selling raffle tickets. Table A relates the cost in dollars to the number of tickets purchased. Table B relates the number of tickets that can be purchased to the number of dollars spent. By interchanging the input and the output from Table A, Julia obtains Table B. A better visual of this, you can see the two tables at the top, Table A and Table B. Table A shows that if you're going to buy one ticket, it's going to cost you $2. If you're going to buy two tickets, $4, 3 is 6, 4 is 8, 6 is 10. So you get a little discount there when you get 6 tickets. But at any rate, then you look at Table B. It shows that if you spend $4, that means you bought 2 tickets. If you spent $8, that means you bought 4 tickets. If you spent $10, that means you bought 6 tickets. So this concept of interchanging your inputs and outputs is the concept of inverse relations and inverse functions. So hopefully you remember the vertical line test. That's a test we use in mathematics to test to see if a graph is a function. We also have something called the horizontal line test, and it tests to see if a graph, or a function I should say, has an inverse. So some notation that you're going to see, do you see this right here? That's the notation we use for the inverse of f. Okay, you can see this this graph we have over here. This blue graph would pass a horizontal line test because the horizontal line would never intersect the graph more than once, which means that this particular blue graph does have an inverse. So we have the idea or concept of a function being one-to-one. If a function passes both the vertical and the horizontal line test, then it is said to be one-to-one, because no x value is matched up with more than one y value, and no y value is matched up with more than one x value. So, with that being said, you did some problems like this in Algebra 2. Very similar. It's going to say determine whether the function has an inverse. If it does, find the inverse function and state any restrictions on its domain. Well, to know if it has an inverse, you can just graph it with your calculator, apply the horizontal line test. If it fails it, then you'd say no, it does not have an inverse. This one does. So to find its inverse, the first thing you do is you get rid of the f of x notation, and you replace that with a y. Then you interchange the x and the y, and then you solve for y. So the next step I'm going to do here is I'm going to square both sides, getting rid of that square root. Then I'm going to add 4 to both sides, and I end up with an x squared plus 4 equals y. So I'm going to write it like this. This is my inverse. F inverse of x equals x squared plus 4. Any restrictions on its domain? Well, you got to go back to the original function, f of x, and if we talked about its domain and range, its domain would be x values greater than or equal to 4, and its range, try to squeeze that in there, would be y values greater than or equal to 0. So the easiest way to come up with the domain of the inverse is to look at the range of the original function. So this domain is going to be x values greater than or equal to 0. All right, 2a. This would pass the horizontal line test if you were to graph it, so our first step is to get rid of the f of x notation, interchange the x and the y. Now solve for y. So I add 16 to both sides. Now I got to get rid of that cube on the y, so I have to cube root both sides. And so I'm going to write my inverse function like this. F inverse of x equals the cube root of x plus 16. Okay. And if we go back to this original problem, the domain You can put any number you want in here, and the range is all real numbers as well. So that's going to be the domain down here. Negative infinity to positive infinity. Okay, example 2, the next one, we have a function, and I don't believe it's going to pass the vertical line test. If you were to type this in on your graphing calculator, you should see a graph that looks something kind of like this. You can see if I were to apply a horizontal line in this area right here, it would fail it. So with that being said, we just come here and we say that f has no inverse. Okay, let's also enter the next one, 2b, into our graphing calculator. Why don't you do that now? Remember, anytime you type in a fraction, you need to use parentheses when you got more than one term, so make sure you put parentheses around that. Otherwise, use your function key the fraction key, like I am here. And when you graph it, you should get a graph that looks something kind of like this. And that does pass the horizontal line test, which means it has an inverse. So, as we go to find its inverse, the first step again is to get rid of that f of x and use a y. Now we have to interchange the x and the y, and we're going to end up with a y on the top and the bottom of that fraction. Now solving for y, we're going to multiply both sides by y to get xy equals y plus 7. And from there, what I'm going to do is I'm going to move this y term right here over to the left so that I have both y's together on the left. Xy minus y equals 7. And then what I have to do is I have to factor a y out of both of those terms, leaving us with an x minus 1. Last step, divide by the x minus 1, and we get 7 over x minus 1. So this is my inverse. F inverse of x would be equal to 7 divided by x minus 1.